Okay, well, you can see what we got here. We're going to be doing, this is the online lecture number 11, and we're talking about paints, coatings, something called zinc-rich paints and anti-fouling. But I've got a special guest lecturer here with me today, and let's see if we can get her on cam. And there you go. There you go. She's in the kitchen with me, and so we're going to we'll pull back here a little bit. Yeah, so here's the, she's very attentive, and here's a look at one of her favorite places, not the sink necessarily, but just the whole place. That this is the magic happens. Now she's staring intently, and what she sees here, there's some lettuce, there's a banana, and there's some doggy biscuits, doggy cookies, as we like to call them. So let's do a little experiment this morning, just for a little bit of fun, and let's see if well, we know she likes dog biscuits. Is that pretty good? Yeah, it's pretty good. Let's see if she likes bananas. These are actually frozen bananas. Pretty good dog treat. Some dogs. Surprisingly enough, you know, we have to clean our palate with a doggy cookie there. And there's the lettuce. I mean, yeah, amazing. This dog likes lettuce. And oh, I'll get that. I'll get that. You get lettuce dropping out of your mouth. She likes salad. One time I fed her cabbage, and she thought that was lettuce, but she was a little bit thrown off by, you know, uncooked cabbage, but she managed to eat that. She likes corn. She pretty much likes all vegetables. Doesn't like onions, but she'll green peppers maybe, but she really has very few limitations. Anyway, so this is you know what? You should go back to bed. Go ahead. You were all done. Go ahead. Go. Oh, I got more cookies here. I'm going to put these away. Come on, you get out of here. Go back to bed. Go. Okay, we got Grace all settled down, and she's still here looking at me down there on the floor. But we are going to continuing to talk about coatings today, and that's still part of chapter 27. And it's still, of course, it's right here. So we talked about corrosion control, and now we're going to talk about anti-fouling systems, anti-fouling paint, for instance. I also want to point your attention to this. Now, I posted an announcement last night just to kind of get you a little bit of heads up there, and I kind of alluded to this in the previous lecture, and I said we weren't going to do a final exam. You knew, well, we didn't have a whole lot of clarity of how this was going to go. But so what I've decided to do, and I've talked to the other profs in the department, and we're going to do something. We're going to do a end of the semester, call it a final drawing project. And you're going to be required to do 2 drawings, all right? So you're only going to have to do 2. And I'm not going to do it like you're going to have to, you know, sit there in front of the cam and do it. I'm not going to do that final exam type stuff. I'm going to give you basically Monday through Thursday of final exam week to do that. I will assign that. You certainly can be thinking about it because I sent you the announcement, but it's not going to be truly assigned as a final project until final exam week, and you saw the date. So check out that announcement. And by the way, if I open this up, it says you'll choose which ones you do, okay? So you're going to be the one, you know, and whether or not it's going to be ship dimensions, you know, like length overall, we had that drawing, and length of the water line, and length between perpendiculars. That's one of the drawings we did. I've got double bottoms out that you can do. I'm going to give you that choice, and I gave you either a fore end or an aft end construction, And so you'll have to, I'm going to give you a list, like choose one of these and choose one of these. And so you can kind of mix and match. Do something, I'm asking you to do it new. Don't give me some old piece that you scanned from your notes that looks like you scanned it from your notes. I want it to be new. I want it to be perfect. Stay with the book, please. And here we go. Okay, just me talking. So there's your first slide. And we're going back to this painting here, or this picture of the old rusty Hulk. And yes. Somebody said the worst enemies of a ship is, what'd you say, time and rust, age and rust. Yeah, I think that's the worst enemies of a ship. So we're going to continue to talk about coatings. Well, the one thing I want you to remember, no, this is not the one thing I want you to remember, but I want you to write this down. Remember this: vehicle plus pigment equals paint. And so paint is made up of pretty detailed formula here, right? The vehicle, and you can think of that as the wetness, and the pigment, that's the color. That's an oversimplification, and that's paint. Well, actually, we don't even call it paint anymore. You don't paint a ship. Yeah, we talk about what are you going to do today in maintenance? Well, you're painting. You're really applying a coating. You're applying a coating. And they're not so much paint manufacturers, but there are coating manufacturers. Let's look at some details here. I need to modify this slightly so you can see everything, and that's going to be the best way to do that. I think we'll go kind of like that. So protective coatings, paints in other words, are intended to obviously protect against corrosion. It's to keep the moisture away from the steel. So first of all, let's go down through the bullets. Pigment dispersed in a liquid, which is referred to the vehicle. Okay, we just kind of talked about that. When spread thinly, it creates a protective and adherent dry film. Now, I want you to focus on that phrase there. Protective and adherent dry film. That's twice. Protective and adherent dry film. I think you know what that means. It's going to show up on exam number 3. Which, by the way, is coming up next week. Coats the steel, separating it from the atmosphere or the seawater. So underneath the water, so underneath this, that would be from the seawater, or up on deck, it would be separating it from the atmosphere. The vehicle changes by way of either evaporation, or it changes, and I kind of put that in quotes there, via a chemical hardening by way of a two-part mix. Now, maybe some of you have used two-part epoxy, maybe in fiberglassing, or you've used the resin in the hardener. So I can't really say that it's an evaporation, but it is a change. It's a chemical hardening by a two-part mix, and we know this as an epoxy resin or epoxy paint sometimes, or an epoxy coating. There are other types of chemical-based vehicle changes used. There's chlorinated rubber, polyurethane resin, and vinyl resins. But I'm not going to focus on that. I told you what I need you to know up here in the upper ones. As we look at a ship, I want you to understand that there are 3 primary areas. The ship is divided into 3 coating areas. And there's this topside area. Topsides in the hull, superstructure, freeboard, the hull, the decks, the railings, and so all of these things right here. And then let's jump down here to everything below the waterline, and that's going to be anti-fouling paint. And you really can't see this color change here, but this area here is called the boot top. The boot top, an area of intermittent immersion, heavy abrasion by the sea, rubbing up against the docks, tugboats, fuel barges that come alongside. That's that boot top area. So there are 3 different types of paint. So it's not all one thing. You kind of probably knew that, but I think that term boot top, and you'll notice that the boot top is usually a slightly different color. So that's kind of interesting. Because the goal is to have a shiny, protected boat, right? I mean, this is really simple, but a shiny, protective boat. Now, one of the things I wanted to talk about here is something called zinc coatings. Now, we talked about zincs last lecture, sacrificial anodes. But this is an interesting specialized coating used instead of or in addition to sacrificial anodes. Those lump pieces of zinc that you attach, bolt, screw on to the side of the ship or underwater portion of the hull. So there's going to be something else here that we're going to use. There are numerous manufacturers within the marine coating business around the world. There are numerous zinc-rich paints. Commercially available, of course, and pretty common. And that is to avoid corrosion. That is to avoid corrosion. Now, that zinc is going to be dispersed. It's going to be an electrolysis, prevent that electrical cell dividing or getting to the hull, and the zinc-rich paint will give up first. Now, let's take a pause there. So, kind of using our whiteboard here, let's just make some notes. Coating, we're talking about zinc-rich paint. Coating should have a high level of zinc dust or powdered zinc as part of the pigment. And actually, I see numbers like a 90% of that pigment, or there should be able to have it's hard to explain, but you should have a 90% level. If it goes down below that, level, it doesn't provide a certain amount or the appropriate protection. But that zinc-rich paint, that zinc dust, provides the cathodic protection for the ship. Now, the vehicle could be any of the previous mentioned. It could be by a drying process. It could be by an evaporative process. It could be by a chemical change process. Any of those methods would work. It's not any one in particular. But let's just think about for a minute, what I want to ask you is what type of vessels might use zinc coatings? Where would it be really important? Now, we've talked about something. We've talked a lot about expense. We've talked a lot about money. And we know shipping companies are not going to necessarily spend money where they don't have to. And sacrificial anodes are very, very good. I mean, they do the trick really, really well. It is an extra expense to have that ship coated. But what particular reason? Think about a vessel that would not want to have those lumps on the side. And those lumps, by the way, would cause turbulence. And I'm going to give you a clue. It would create an inability to maintain certain stealthiness if you were in the water. There's the clue right there. Stealthy. To be stealth-like. To be hidden. And think about a military vessel, and in particular, think about a submarine. Think about a submarine that doesn't want to be understood where it is. And you don't want to have any exterior turbulence around the hull. And that might be, now I don't know, if I were to tell you, I'd probably, they'd have to take me out if I told you that. But I suspect that, that might be a really good application. So just a little bit that you could know about. Think about what I just told you there. It would probably be, it's going to be more expensive, but it's possibly might be something like a submarine. It might be a research vessel that was going through the water. And you're doing acoustic surveys, and you don't want any of that background noise. Now maybe that's it. Now, the state of Maine, was a hydrographic survey vessel, but she wasn't in that class of ship that she had zinc-rich paints. Anyway, moving on here. So we want to go on to anti-fouling. So here's a pretty severely fouled hull. You can look at I'll try to remove this picture, and you can see just how bad it is. We get the labeling out of there, and you can just see the extreme amount. This vessel's in a dry dock. Here's the bilge strake right here in this area. You can see the turn of the bilge. And up there I can see where it kind of ends, that we're getting up maybe towards the boot top area. And I can see the blocks under the ship down here in the dry dock. So not a particularly large ship, but awful lot of corrosion in here. So we are talking about anti-fouling paints. So we're talking about the immersed hull and the fittings, various things under the hull, you know, the stern frame and the bow thruster and all those fittings, and any gratings over any intakes for seawater through hull fittings on the bottom of the ship where it would be able to pull in. And anti-fouling, you know, it's particularly true in coastal waters, because that's where the most growth occurs. You don't necessarily think about this, but you'll see this someday in your life. When you go out in the middle of the ocean, the water is incredibly clear. You would be surprised how deep you could see, and you can't actually tell because there's no reference. But the middle of the ocean is kind of like a desert, in that there's not a whole lot of stuff going on there. It's when you're in coastal waters that you get more marine growth, both animal and vegetable marine growth. So you got algae, we get barnacles, we got mussels and other shellfish. This growth inhibits the efficiency of the hull and the performance and the hydrodynamic performance of the hull. Let's take another look at a ship here. Here's a Maersk ship that's tied up at the dock, and it's floating quite high. We see the bow structure. And what we see here, right on this particular area, this is where I want you to focus. Yeah, you can take a look at the lines and, you know, understand how they're tied up. And, you know, we talked about the lines of a ship way back in a few classes ago, like back in Introduction to Naughty Sci. Do anybody remember what this? This is the offshore headline. This is the onshore headline, another onshore headline coming down. This looks like it might be a breast line, and right there it looks like we've got a spring line leading aft. So those are words that are going to become familiar with you as you get to sea. But today we want to talk about this right here and what's happening here. And I'm going to focus in on something. I want to change that image a little bit. I'm going to zero in on just that particular shot. I want to zoom in. Now look at that. Boy, what the heck's going on there? Look at this. Look at this striping. Now I think I don't know, but I think this is barnacle growth on the hull. Barnacle growth on the hull. Now it takes a long time for barnacles to grow. That doesn't just happen overnight. But one of the things that I see this little like stripe area back here, not this one. I also see this area here, the very front of the bulbous bow. Then I see this striped area here. And then I see this different stripe area back here. Well, let's talk about all three levels, or all three things. First of all, the front of the bulbous bow, that takes an awful lot of wear and tear when the ship's going through the water, and that almost probably wears the barnacles off just because it's right there. You know, it's the blunt end of the bulbous bow. Well, what about this stuff right here, these stripes? Number one, we got 1, 2, 3, 4, 5, and then, I don't know, there might even be a couple more here. You know what I think that is? I think when these lines are dropped in the water and when the ship leaves the dock, let me go back here. When the ship leaves the dock, you have to slack this line off. It drops in the water, and then it has to be winched up on deck. And I think that the friction of that line as it comes across the bulbous bow, I think that's what scrapes those barnacles off. Now, back here in this area, I think something is different. I think what we're seeing there is the ribs of the ship. I think we're seeing the ribs of the ship. That's where, you know, and then I see that cupping between the frames, the ribs, the frames of the ship. A little bit of a cupping, you know, it might be a ½ inch that those barnacles, that steel plate is set back in a little bit. You know, you've seen that on the training ship. And when you get the sun just right, you can see that cupping between the frames, particularly on an old ship, an older ship. And that's Remember, that was called that force of the ocean and just the wear and tear on the ship, and that may have been associated with the waves hitting the ship and just the stresses involved. Well, that's kind of interesting stuff. So anti-fouling paint. Let's see here. These coatings, let's see. Pigments and vehicle are mixed with a material which is toxic to marine and vegetable growth. Okay, so people figured this out a long time, centuries ago, that there was marine growth that was going to be damaging hulls. You know, back in the days of sailing ships, you know, 200 or 300 years ago, and the great warships of the French and the Spanish and the English, and in the Pacific, you know, of the Asian and Chinese and Japanese warships, all of those things, they determined that in those coastal waters, you know, those vessels had to be protected. They would actually use thin copper plates, and they would tack those plates on, nail those plates onto the outside of the ship to provide that protection. They didn't have any other way of doing it, because otherwise, you know, there was growth that was going to be would drill itself into the wood, the timbers of the ship, and it would cause damage to that. Well, we don't do that nowadays, but it certainly, that's what they did back in the day. Copper was the best known toxin and continues to be traditional used in anti-fouling paints. For effectiveness, that toxin should release from the paint, and here's some key words that I'm going to point out to you. Yeah, I'm going to say them 3 times. At a controlled and known rate. They are going to release from the paint, from the coating, at a controlled and known rate. One more time. Controlled and known rate. What makes it all work? Yeah, the toxin, but it all can't come out in, you know, just 2 or 3 months. It has to be done at a known controlled rate. You know, if you're a lobsterman on the coast of Maine, or maybe you grew up on the coast of Maine, or maybe you know something about this. You know, we haul the boats out in the springtime. We do it in the springtime because you know, most of the marine growth is going to happen. It's going to happen when the water gets a little bit warm. So you'll see lobster boats, you know, coming up on the shoreline. And the way the lobster boats are constructed, you can just let them beach right out, and the tide goes down. You apply the paint, and the tide comes back up, and off you go. And it's as simple as that. I mean, there are other ways of doing it. You can go into a shipyard or onto a railway, but an awful lot of fishermen would do it that way. The rate must be to a degree to reach the toxicity level to inhibit plant or animal growth. AF, which is anti-fouling paint, was previously good for about 12 months. And you can still buy anti-fouling paint. That is the least expensive. 30 years ago, the industry reached a 24-month protection period. So you only had to apply it once every 2 years. Nowadays, we anticipate as much as 5 years worth of protection. And so that goes into the commercial industry, where we're pulling a ship every 5 years up into the dry dock and recoating the hull. So there's just some facts about it. Coating suppliers have developed something a little bit different. It's called a self-polishing anti-fouling product, which in addition to containing toxins, has a tendency to wear smooth as the vessel goes through the water. Now, you wouldn't think a whole lot of friction could you know, between the water and the steel, but you know, water does create some smoothing effect. The smoothing actually serves to inhibit marine growth by making it difficult for the little, you know, either the little feet of the little shells or the barnacles, or, you know, the attachment point, or the actual organic growth of, you know, a plant. It's difficult for the growth to attach itself to the hull. It also, because it's a smoother hull, it increases the efficiency, the fuel efficiency. Well, that's kind of interesting, except it goes one step further. There is another class of anti-fouling paint which has no biotoxins at all. It relies completely on the extreme smoothness factor. That's interesting. And a notable example of how this happens. A notable example, it appears when ships are coated thusly. In other words, it's got this class of extreme smoothness, so smooth that the little organisms, whatever they are, animal or plant life, they can attach, but they have such a poor attachment. And the ship is in port for a long time, the vessel's in port, and as the growth is there, as long as the vessel's not moving, but as soon as it gets underway, upon getting underway and transiting to what's called sea speed, in other words, it's operational speed, maybe for a big container ship or a tanker, maybe, 13, 14, up to maybe 20, 22 knots. Upon getting up to sea speed, that growth just sloughs off. It falls off because with the water passing by, it just can't get enough grip. So that's interesting too. Well, I told you a lot about stuff, and listen, we're going to come back and we're going to talk about. Let's just go back as I finish up just this talk here. Now, I'll try to take this. Take that out of there. So we got something to look at as I talk. So, hey, listen, we got some tests coming up, some projects. I see that I like all but 2 or 3 of you, and I know I got one person who's got a legitimate excuse. They called me, and I'm talking about not getting that report for the Herald of Free Enterprise and the Estonia. Poor Tom, I don't know if you know this, but Tom McLean is over in Dedham, Maine, not that far from Bangor or Brewer or even Castine, without power as of yesterday. I'm hoping, Tom, you're hearing this, and God, and still without power. So we're coming up on a week without power. There are a few people in Maine, so he's got an excuse. But there was other couple. I think you just missed it. I don't want to say your name, but your initials are GB. So you guys who missed it, that's one who I remember. So GB, what's up? What's up with that? What's up? Why don't you contact me? Why don't you give me a good reason for that happening, and we'll get that fixed. I'll give you a little bit of break. It's going to cost you a little bit. You don't have an excuse beyond you just forgot. And we got just a few more lectures coming up. Not a whole lot. I think I want to talk about some sea trials and just a few more things. There's not very many lectures coming up. I'm going to do the exam. And then, by the way, the exam's going to be an open book. It's going to be an open book. I'm not going to use Respondus for that exam, which is going to be next week, and I'll give you a whole 24-hour period to do it. So watch for information there, and so on and so forth. Okay, everybody, talk to you later. Bye-bye.